Hello, my name is Zachary Kushner, and this is my final project for Comp3005, a health and fitness club management system built using PostgreSQL and Python. In this video, I will walk through my diagram, relational mapping, normalization, SQL schema, code structure, and a demonstration of member, trainer, and admin features. So the first thing I want to show is the diagram. It models the complete workflow of a fitness club. I included 10 core entities: trainer, trainer availability, admin staff, class, room, health metric, PT session, member, class registration, and fitness goal. Members can have multiple fitness goals and health metrics. Trainers can teach classes and also set availability windows. Classes occur in rooms, and members can register for them through a many-to-many join table. Personal training sessions link members, trainers, and rooms in time-based appointments. This ERD fully supports membership management, class scheduling, trainer availability, health tracking, and personal training bookings. I'll now show the mapping. So, in this mapping, each entity becomes a table with a primary key. All relationships are captured. Sorry, one second, I'll just make it easier to see. You guys can see it all at once. Each entity becomes a table with a primary key. All relationships are captured using foreign keys. For example, the fitness goal and health metric tables each include a foreign key back to member. Classes reference both trainer and room. PT session references member, trainer, and room simultaneously. The class registration table captures the many-to-many relationship between members and classes with a composite unique constraint to prevent duplicate registrations. This mapping fully preserves the logic of the original model. Now I'll talk about normalization. So this schema satisfies the first, second, and third normal form. All attributes are atomic, and all tables have proper primary keys, which satisfies the first normalization. There are no partial dependencies, so the schema is in 2NF. There are no transitive dependencies, meaning every non-key attribute depends only on its primary key. This prevents redundancy and ensures that updates, inserts, and deletions do not cause abnormalities. So the next thing I'll show is the DDL. So this is where I create the tables. It specifies their primary keys and foreign keys and defines constraints such as not, null, unique, and capacity rules. I also implemented the advanced SQL requirements. One view for the member dashboard summary, one trigger that prevents trainers from creating overlapping availability slots, and one index to improve schedule-based lookups. The entire schema loads correctly into PostgreSQL. Now I'll show the sample data, DML. We have admin staff, trainers, members, rooms, fitness goals, health metrics, trainer availability, classes, and some more things. I included at least 3 to 5 entries in each table so that I can fully show this application to its fullest extent. Now I'll start with my demonstration. So to run it, all you have to do is python free app/main.py. I'll make this bigger for you guys to see. So this is the basic UI. Very simple, very easy to use. First, I'll demonstrate the member role. So member, select one, boom. Now we have a bunch of different options to choose from. I'll start by registering a new member. We'll name him Zach, and his email will be zach@gmail.com. His date of birth, optional, gender optional, phone optional. We don't need that stuff. So, 1 second. Next, I'll add a health metric. So we just do zach@gmail.com. And we're adding the metric for Zach. Well, put my current weight at, let's say, something ridiculous like 50 kg. We don't care about heart rate. Body fat, doesn't matter. Now we'll add a fitness goal for Zach. So to add a fitness goal, we press 5. Enter member email, zach@gmail.com. Get real big. And the target weight will be 100 kilograms, so I want to double my weight, which is kind of funny. So now to check, I just have to click on View Dashboard. So I'll enter Zach's email again. And right now, Zach weighs 50 kilograms, and his goal is to get to 100 kilograms, which is pretty big goal. I think this is a very good interface for a console, and yeah. So now I'll leave the member menu and I'll show the trainer features. So first I'll set a trainer availability window. If I enter a valid non-overlapping time slot, it will be saved successfully. But first we have to find the trainers. So we can go into get the names of the trainers. There's Tom Trainer Fit Com. Let's put his email in. Will it work? Nice, it worked. Here's the format. What format should we give him? Let's say 2025 012. 012 12 01 12 25 2025-12-01 let's say 1845. So it was successful. That's good. But I'll show you an edge case where it won't work. So right now, from today, from noon to 6, he should be available. So if I try adding another one at the same time, it should not work. So add one from 1 to 2. See, error, this availability overlaps with an existing time slot. So because I had already made it, he can't anymore. It's a very simple system. It works quite well. And then if I press view schedule for him, you can see the schedule. Pretty cool system. Now I'll show the admin features. Okay, so admins can create rooms by specifying a name and capacity. So we'll call this room Carlton's Gym or something like that. And we'll put the capacity at 100. Now, if we list for rooms, we have Studio A, Studio B, Carlton's Room 1, Carlton's Gym, 100 capacity. It's added. Now, I'll attempt to create a class. First, we'll list the classes to see what we have. So right now, there's morning yoga, lunch spin, and strength basics. If we add a class, I'll just call it biking class. Trainer email, Tom Trainer, the club, room name. Check for room names again. We'll do Studio B. And start time, let's just put December 4th, 25/04, 25/12/04 from 1 to 2. Entering dates is always a bit of a pain on a console. Let's just put, then Studio B, it has to comply, so we'll just put 10. Nice, so it's created successfully. Now I'll just list the classes again. And we have biking on December 4 from 1 to 2. The trainer is Tom Trainer in Studio B, and there's a maximum amount of attendees as 10. That's great. Yeah, I think that's good. So to finish, here are the advanced SQL components implemented in DDO.SQL. So I'm done with my presentation of the features. So the first one is trigger. Sorry, where is it? I don't. So the trigger prevents overlapping trainer availability. Next, the index improves time-based lookups. Finally, the view powers the member dashboard. So, in summary, my system implements all required database components, supports more than 8 functional operations across all 3 rows, includes a complete ERD with mapping and normalization, and uses advanced SQL features like views, triggers, and indexes. Thank you for watching my final project demonstration. Have a good evening.